So children, today we will revise reproduction, adolescence, electricity of 8th class. 8th class, small revision children. So coming to reproduction. So children, already we have studied that reproduction. What is in reproduction? It's the biological act of creating and producing offspring. It's a biological act of creating and producing offspring. It's a biological act of creating and producing offspring. There are two types of reproduction, sexual and asexual reproduction. One second. So there are two types of reproduction, children, sexual and asexual reproduction.
Sir, there is no one else in the class.
Yeah, one second. Let me know. I know. Okay, so there are two types of reproduction, sexual and asexual reproduction. What is meant by sexual reproduction? Only single organism is involved. What is meant by asexual reproduction? Asexual reproduction means two organisms are involved. Okay, here because sexual reproduction means two organisms, male and female are involved. Here only single organism is involved. Sexual means two organisms, male and female. Because male and female are involved, male and female gametes are formed. Because male and female gametes fuse, fertilization takes place. Okay, fertilization takes place. Because fertilization takes place, variation occurs. Because variation occurs, evolution it is useful. Sexual reproduction is good, very much useful for evolution. And here single organism is there, so no gametes are formed. Because there are no gametes responsible over, no fertilization. Because there is no fertilization, no variation. Because there is no variation, evolution will be very slow. Just I am doing a revision of reproduction, adolescence, and electricity. Okay. So now different types of asexual reproduction we studied is fission. Fission we saw in amoeba. Okay, and budding.
Sir, budding.
Budding we saw in eastern hydra. Budding we saw in eastern hydra. Next I told regeneration. Regeneration we saw in planarium. Regeneration we saw in planaria, and then we saw what else? Spore formation. Spore formation we saw in rhizophus. Rhizophus. Okay. Now coming to sexual reproduction in males and females. Sexual reproduction is next male reproductive system. Coming to male reproductive system. What is the male reproductive system? Main part testis. Testes are present in scrotal sacs. From testis, what will come? Spermatic duct and vas deferens. Spermatic duct convert into ureter. Sorry. Spermatic duct converts into urethra. Urethra is protected by penis. And at the junction of urethra, we will have three glands. What are the three glands called? Prostate, seminal, and corpus. These are the glands which are present. So, what is the function of testis? Testis produce sperms and testosterone hormone. You should learn diagram also compulsory. Without diagram, no marks. Testis produce sperms and testosterone. Scrotal sacs largest testis. Why testes are present outside the abdomen? Because they cannot withstand high human body temperature. Testis cannot withstand high human body temperature. Spermatic cord stores and transfers sperms. Stores and transfers sperms. Urethra. Urethra is called as urinogenital duct. Urethra is called as urinogenital duct. Why? Because it helps in passage of urine and also passage of sperms. Penis. Penis is a copulatory organ. Penis is a copulatory organ. Penis is a copulatory organ. Okay, which helps during sexual intercourse. Prostaglandins, seminifericans, corpus glands secrete a fluid which gives what will this fluid will give? Lubrication and nutrition to the sperms. It will give lubrication and nutrition to the sperms. It will give lubrication and nutrition to the sperms. Okay. Next, coming to female reproductive system. Female reproductive system most important structures are ovaries. Okay. From the ovaries, what you get, children? Okay, ovaries, and you also have oviduct, and you also have uterus, and you also have vagina. Okay, ovaries produce ova and estrogen hormone. Ovaries produce ova and estrogen hormone. Oviduct is site of fertilization. Oviduct is site of fertilization. Means sperm and ova will unite their own. Oviduct is the site of fertilization. Oviduct is a site of fertilization. In uterus, implantation takes place. Means implantation means attachment of zygote to uterus. Attachment of zygote to uterus. Attachment of zygote to uterus. And in vagina is a copulatory organ in females. Vagina is copulatory organ in females. Okay. If fertilization takes place, What is fertilization? What is the fertilization? Fusion of
Fusion of male and female gametes in
fusion
ovule.
of male and female gametes. Fusion of sperm and ova. Fusion of sperm and ova, which occurs in ovula. And if zygote is formed after fusing, then it will form embryo. This embryo gets attached to uterus. Attachment of zygote or embryo to uterus is called implantation. Attachment of zygote to uterus is called implantation. After implantation, placenta is formed between mother and fetus. Placenta is formed between mother and fetus. Placenta is formed between mother and fetus, which gives nutrition, respiration, circulation, excretion. After the end of 9 months, due to contraction and relaxation of uterus, baby comes out through vagina. Baby comes out through vagina. Along with that, frog life cycle also you have to study. External fertilization occurs in frog. Okay, larval stage is there, and tadpole stage is there, and adult stage is there. And entire transformation of larva to adult is called metamorphosis. Gradual transformation of larva to adult is called transformation. Metamorphosis. Gradual transformation of larva to adult is called metamorphosis. Metamorphosis means entirely change. Larva and adult don't have any resemblance to each other. This is Alexei. So children, just I'm doing revision children of all lessons. Next we will do adolescence. Okay children? Then in adolescence lessons also children, we have seen what are the changes occurring during adolescence. I told you what are the changes occurring during adolescence. Children, what are the changes occurring? I told you. I told you list. I gave you the list one by one, one by one, one by one. I gave list. What are the changes occurring in adolescence? Increase in height. Okay, I told you because of pituitary gland, height will increase. And also I said change in body shape. Broad shoulders in male, broad pelvis in females. Change the shape. Change in voice. Voice will low pitch in males, high pitch in females. Body hair in armpits and genital organs. Okay, and increased activity of sweat glands and sebaceous glands. Sweat and sebaceous glands activity increases. Emotional changes, anger, love. Okay, attraction to opposite sex, emotional changes, and even in males, females, menstrual cycle will start. Menstrual cycle. The onset of menstrual cycle is called menarche. The onset of menstrual cycle is called menarche. It starts at the age of 12 to 15 years in all adult females. Okay, in all adult females. Okay, children. Next, it will stop after some days. That is called menopause. It will stop after some days. That is called menopause. It will stop after some days. For some days means 40 to 45 years. It will stop. That is called menopause. Only between these two periods, females will be able to reproduce. Okay, this is called reproductive period during in females. What is menstrual cycle? I told it is calibrated from 1 to 14, 14 to 28, and 2 to 7 days. Okay, 1 to 14 days, ova will be forming. Ova will be forming in ovary. 1 to 14 days, ova will be forming in ovary. 1 to 14 days, ova will be forming in ovary. Exactly on 14th day, ovulation occurs. Means ova is released into oviduct. It will they live for 2 days. In these 2 days, if sperms are coming, fertilization occurs. If not, it will die. And 14 to 28 days, uterus will be preparing endometrium for uterus is preparing endometrium. Why uterus will prepare endometrium? For if ever if ever zygote comes, it gets implanted here. Thinking that fertilization occurs, uterus will prepare endometrium. 14 to 28 days, thinking that fertilization occurs, uterus will prepare endometrium. Thinking that implantation occurs, uterus will be preparing endometrium. If fertilization does not occur on 28th day, endometrium, blood, mucus, ova, everything comes out in the form of menstrual cycle. Okay, this occurs in all females. For 2 to 7 days it will occur. Again, it will start 1 to 14, 14 to 28 because two ovaries are there. No? One ovary 1 month, one ovary 1 month. One ovary 1 month, one ovary 1 month. Alternately, they will take up the function. Alternately, they will take up the function of this formation. Okay, this is menstrual cycle. And I also told in adolescence lesson about various glands. What are the glands I told? Pituitary gland. Okay, pituitary gland is present in the base of the brain region I told, and it will secretes growth hormone I told. It secretes growth hormone. Next, number two, I told thyroid gland. Where is thyroid gland present, children?
Neck.
In the neck region. It will secrete thyroxine hormone, thyroxine, and it will control metabolism of carbohydrates, fats, and proteins. Metabolism of carbohydrates, fats, and proteins. Metabolism of carbohydrates, fats, and next back of thyroid gland, parathyroid gland is present, which will controls calcium and phosphorus levels in the body. Calcium and phosphorus levels in the body. Next we have pancreas. Pancreas will secrete what hormone? Insulin. It will control the sugar levels in the body. Pancreas secrete insulin hormone which controls sugar levels in the body. Pancreas insulin. Adrenal gland. Adrenal gland secretes adrenaline hormone which is released during stress conditions. Adrenaline hormone is released during stress conditions. Testis secretes testosterone hormone, which is released during, which helps in getting secondary sexual changes. All the secondary sexual characters are observed because of testosterone. Next, estrogen. Estrogen hormone brings up female secondary sexual characters. Female secondary sexual characters. So, so what are the hormones I told children? What are the hormones? Pituitary gland will secrete growth hormone. Okay. Thyroid gland will secrete thyroxine hormone. Thyroxine hormone. Parathyroid gland secretes parathyroid hormone. Okay. Pancreas will secrete insulin. Pancreas will secrete insulin. Adrenal gland will secrete adrenaline. Adrenal gland will secrete adrenaline. Testis will secrete testosterone hormone. Ovaries will secrete estrogen hormone. Like these hormones and their functions you have to study, which I have given the list also for you. Next, we'll study, so children, we revised reproduction and adolescence, then we'll revise electricity. Then we will revise electricity, a small revision. Okay, children, coming to electricity. So children, in electricity, I hope you all remember what is in electricity. So we discussed what is positive charges and what are negative charges, how each charges will go to one second children. So I told you about in the electricity, direction of flow of current, electric current, electrolyte, all those things I told. So children, the substances which are good conductors of electricity are called conductors, which are bad conductors are called insulators. Which are bad conductors are called insulators. Electric current. Okay, children, if you see a circuit, electric current we will take from positive to negative, that is called convectional current. That is called convectional current. We will take positive to negative, children, that is called convectional current. Electric flow will take from positive to negative, that is called convectional current. Okay, children. Now, what is an electrolyte? I was discussing about electrolyte. What is an electrolyte, children? What is an electrolyte? Substance which decompose into cations and anions. Substance which decompose on passing current. What is an electrolyte? Substance which decompose on passing current. Electro means what, children? Current. Light means break. On passing any current, if a substance break, that is called electrolyte. On passing a current, if a substance break, it is called electrolyte. On passing a substance, on passing a current, if a substance break, it is called, like suppose NaCl is there. If you pass current, it will break up into Na plus and Cl minus. Suppose HCl is there. If you pass current, it breaks up into H plus and Cl minus. Suppose water is there. If you pass current, it breaks up into H plus and OH minus. Suppose CO2 is there. If you pass current, it won't break. It's not called as electrolyte. It's a gas. Okay. So substance which breaks up into ions. Suppose like you have calcium sulfate. On passing current, it breaks up into Ca plus 2 plus SO4 minus 2. Suppose you have Al2PO4 taken thrice. Okay. On passing current, you will get Al plus 3 and PO4 minus 3. Like this, a substance which breaks up into ions and passing current is called electrolyte. Okay, strong electrolytes are those electrolytes. What are strong electrolytes? Which decompose completely, which break completely. Strong electrolytes are those electrolytes which decompose completely. Weak electrolytes are those electrolytes which decompose partially. Which decompose partially. Weak electrolytes are those electrolytes which decompose partially. Strong electrolytes decompose completely. Weak electrolytes decompose partially. Strong electrolytes decompose completely. Weak electrolytes decompose partially. Now, what is electrolysis? Okay, what is electrolysis? Is a process where when current is passed through a electrolyte, it breaks up into cathode, anode, everything, cations, anions, and liberating it there. Okay, so the solution that conducts electricity is called electrolyte. Solutions that conduct electricity is called electrolyte, and process is called electrolysis. Substance which conducts current is called electrolyte, And this process is called electrolysis. This process is called electrolysis. Basing on this, we have studied two applications also. One is electroplating we studied, and the one we studied electrorefining. Do you remember, children? What are the conditions of electroplating and electrolytic refining?
So
Children,
the substance, the metal to be electroplated should be cathode, and the metal which is being electroplated and the metal which is to be electroplated should be anode, and the electrolyte should be a salt of the metal to be electroplated.
very good, fantastic. So, children, electroplating. Those who forgot about electroplating, I will give once again. Children, this is an electrolyte. In this, we will take electrolyte. In this electrolyte, cathode, anode. Sorry, anode. Anode is that which is connected to positive terminal of the battery. Cathode is that which is connected to negative terminal of the battery. Okay, children. Electroplating means imagine I have an iron nail. I want to plate it with silver. I want to coat it with silver. Silver I should take at anode. Silver I should take at anode. Whichever is taking my coating, I should keep at cathode. Iron I should keep at cathode. And electrolyte which I am taking should be silver salt, some silver salt. So that when you pass current, silver from anode, silver from electrolyte will come and settle on cathode. Why? Because silver is a metal. Metals always lose electrons. On losing electrons, they become positive cations. Cations always goes to cathode because cathode is negative. Metals always goes to cathode. Metal always goes to cathode because metals are cations. Cations are liberated at cathode. No, sir, we didn't understand it. One more example. Suppose, okay, children, that thing which we connect to positive terminal is called. One second, sorry. That thing which connects to positive terminal is called anode. That thing which connects to negative terminal is called cathode. Suppose I want to galvanize. I want to coat zinc on aluminium. Galvanization. Coating of zinc is called galvanization. Coating of zinc is called galvanization. Whatever I want to coat, I should keep it at anode. Whatever I want to coat, I am giving coating. That keeps whichever is taking, that you should cathode. That should be cathode, and electrolyte should be salt of the metal to be coated, zinc salt, some zinc salt. Salt means what, sir? Means zinc chloride and zinc oxide or zinc nitrate, something, some salt. Now when you pass current, zinc from electrolyte, zinc from anode will go and fall on the aluminium, and aluminium will get zinc coating. Aluminium will get zinc coating. Coating of zinc is called what, children? Galvanization. Coating of zinc is called what, children? Galvanization. Coating of zinc is called what, children? Galvanization. Okay. No, sir, I didn't understand. It's one more example. Children, it's one more example. Okay. Suppose that thing which we connect to positive terminal of the battery is called anode. That which will cathode, anode, cathode. Okay. Suppose I want to do tin coating on lead. I want to do tin coating on lead. Tin you should take at anode. Cathode you should take lead. And what salt will take, children? Tin salt. Any tin salt, your wish. Any tin chloride, tin bromide, tin nitrate, anything. On passing current, children, tin from anode, tin from electrolyte will go and settle on lead. Coating is done. So, children, in electroplating, which we give coating should be at anode, which take coating should be at cathode, and electrolyte should be which we coat, salt of the metal which we coat, salt of the metal which we coat. Okay, children. So this is electroplating. Surya, can you tell what is electroplating? Coating of
Sir,
one metal on another.
on another material.
On another metal. How do you coat? What are the conditions? Cathode, anode, electrolyte. What are the conditions?
Sir, when you need to have an electrolyte which is mixed with acid, base, and salt.
What you're taking?
Electricity
We need a anode. We need a cathode. What should be anode? What should be cathode? You tell it off. I want to coat gold on iron. Then gold should be kept near. Gold should be kept near
Yes, sir.
anode. Iron should be kept at cathode.
Yes, sir.
Whichever you are coating should be kept at anode. Whichever is taking coating should be kept at cathode. Electrolyte is salt of the metal to be purified. Okay, children. Next, electrolytic refining. Next, electrolytic refining. Electrolytic refining means I want to purify any metal. Suppose if I want to purify copper, whichever I want to purify, please see here, which is connected to positive terminal is called anode, which is connected to negative terminal is called cathode. Impure copper, which I want to purify, keep it at anode. Pure copper, which is already existing, keep it at cathode. Electrolyte should be salt of the metal to be purified, salt of the metal to be purified, salt of the metal to be purified. What happens? When you pass current, all the impurities are left here, all the impurities are left here, and copper from here and copper from electrolyte will go and settle on pure copper. Okay, children, those who did not understand. Suppose I want to purify iron. Okay, impure iron I should take as anode. Pure iron which is already existing, I should take it as cathode. Electrolyte should be salt of iron. Salt of iron. When I pass current, okay, pure iron from impure iron, pure iron from impure iron leaves all impurities here and goes and settles on cathode. And pure iron from electrolyte also goes and settles on cathode. Suppose I want to purify aluminium. Impure aluminium, take it as anode. Impure aluminium. Pure aluminium, take it as cathode. And salt should be aluminium salt. When I pass current, pure aluminium from here comes and settles on cathode. And from electrolyte also, pure aluminium will come and settle on cathode. So, how do you purify, children? What are the three conditions? Impure metal is always taken as anode. Impure metal is always taken as anode. Pure metal is always taken as cathode. And salt, children, salt of the metal to be purified. If I am purifying iron, take iron salt. Don't take copper salt. If I am purifying copper, take copper salt. Don't take iron salt. Impure metal, take it as anode. Pure metal, take it as cathode. And electrolyte should be salt of the metal to be purified. Electrolyte should be salt of the metal to be purified. Whereas in electroplating, what is anode, what is cathode, what is electrolyte? Anode is that which we give coating, and cathode is that which take coating, and electrolyte is salt of the metal which we give coating. Salt of the metal which we give coating. If I want to coat silver, take silver salt. If I want to coat gold, take gold salt. If I want to take coat zinc, take zinc salt. So here anode is impure metal, cathode is pure metal, electrolyte is salt of the metal to be purified. Here anode is which we are giving coating, cathode is which is taking coating, electrolyte is salt of the metal which is giving coating. If you can remember this, children, and remembering all are small, what is a cation? Positive charge ion is called cation. What is an anion? Negative charge ion is called anion. What is an electrolyte? Substance which conducts electricity is called electrolyte. What is electrolysis? Breaking of electrolyte into ions. How ions are broken down? I showed you. So many ions I have shown you how they break up. Okay, like that when you pass current, they decompose into cations and anions. Cation is positive, anion is negative. Cation is positive, cation. Children, cation is positive. Cation is positive. Children, cation is positive. But cathode is negative. Don't get confusion, children. Please. Many people will get confusion. Cation is positive, but cathode is negative. Cations are liberated to cathode only, because positive goes to negative. Cations are liberated at cathode because positive goes to negative. Cations are liberated at cathode because positive goes to negative. Cations are liberated at cathode because positive. Metal form always cations. Why? Metal always form cations. Why? Because metals give electrons. Total stability. Total stability. Metals give electrons. Total stability. Metals give electrons. On giving electrons, they form cations, and cations are liberated at cathode. Metals give electrons. On giving electrons, they form cations. Cations are liberated at cathode. Metals give electrons and they form cations. Cations are liberated at cathode. Metals give electrons. On giving electrons, it form cations. Cations are going to cathode. Why they give electrons? To attain stability. Why they give electrons, children? To attain stability. Okay, children, I hope you understood. Thank you so much, children.